we start with the introduction of BPP publications. BPP is Asia's largest publishers of technology books. For the past 63 years, BPP has been a friend, philosopher, and guide for programmers, developers, IT professionals who have made things happen in the IT world. It was started by Shri G.C. Janji, who has been honored with the Padam Shri Award in 2002 by Honorary President of India for his contribution in spreading IT education in the country. So it's a great honor and pleasure to invite the speaker of the day, Dr. Patanjali Kashyap. Dr. Patanjali is working as technical project manager at Wells Fargo. He's a technical expert on .NET technologies, cloud migration, and database systems. He is an expert in Agile process, Prince2 and Microsoft certified professional. He is an author of multiple research and white papers on various topics like Agile, AI, NanoTech, and DNA computing. So we welcome you, Dr. Patanjali, and please start the session. So over to you. Please share your experience with our participants. Thank you so much. Yeah.
I'm just trying to throw my screen. Let me know if you are able to see my screen. Are you able to see my screen?
No. No, please. There is an option present now where you can just... Yes, yes, right.
So my screen is visible?
No? Yes, it is visible. Yes, please.
Okay, I'm flashing it.
Yeah. Thank you so much.
Is everything clear?
Yes, it is clear. Yes, okay. Please.
Hello all, my name is Patanjali Kashyap and thanks Survi for your nice introduction about me. Just to brief you, as Survi mentioned that I'm working as a technical project manager in Wells Fargo, India Limited, located at Bangalore. On day-to-day basis, I'm involved in handling .NET projects and some innovative projects related to big data, IoT, and artificial intelligence. Although preparing myself as the world is going towards the quantum computing, so preparing myself as well for the quantum computing world. So that is one of my main agenda for life in next few years. So that is on the interest part. As far as my personal achievement is concerned, there are a lot of professional things which I can talk about, but personally what I feel that writing few books on machine learning and quantum computing is one of the achievement which I can mention to you. One of my book is already published with APRIS, and that is machine learning for decision maker. Other one is again in the narrow pipeline with BPP. So that is on the quantum computing, and you will expect the book in next few months. So this is in brief about me. As you see from my profile that I did my master's in computer science and physics. So this is an obvious inclination towards the quantum computing and therefore to electronic based system like the traditional computing system. So I worked on .NET, I worked on data warehousing, I worked on database systems and so on. So This is in brief about me. We will go to the agenda of our topic, what we are going to cover today. However, we have a time of just 1 hour, and by seeing this, you will see a lot of items to be covered. Uh, Based on the time we will move forward, I will try to cover as much as possible we can. But the ultimate goal is very clear. What we are trying to cater in this session for 40, 45 minutes or 50 minutes is to give a holistic understanding to the audience that how multiple technologies, and which we are generally talking in these days as a deep technologies, or one part of it as a digital technologies, that the how these technologies work together and how these technologies are going to impact our future. What would be the future based on these technologies? So in short period of time of 1 hour, obviously this is what we can cover. And apart from that, if you want to explore the things more, obviously I am available on my LinkedIn and the other social media site, where you can definitely come to me and we will discuss on the multiple things. I assume few things. I assume that you have at least basic understanding of these technologies. So I will not go into the very detail of it. Having said that, at the same time, I will make sure that you will get a brief about all these technologies, so that we will finally able to relate multiple technologies uh, to each other. So we will start with covering with the first section will mostly towards the understanding cloud computing in the Internet of Things, big data, artificial intelligence, and machine learning. Obviously, the brief of it. And the second part of this presentation will focus on basic fundamentals of quantum computer, how the quantum computer work, and how it is different from the traditional way of doing the computation. Then in the last part of this presentation, which is the third part, where we will see that how these technologies, which we are saying digital technologies, and then again deep technologies like quantum computers, work together to give you something interesting. How in the next 10 to 20 years or 30 years, how the industry will shape and how your future will be shaped based on these technologies. So this is what the agenda of this presentation. Moving forward, to make it, to set the context, I will start with this classic slide, which I generally use in my presentation. And this slide depicts that the how the change happened uh, in uh, in Bollywood. You see that we started our journey in Bollywood as a, the film which didn't have a voice, the film which didn't have a color, and it started from there, and mostly the spiritual content is there. And we move forward towards latest hit, and then we see Robot 2.0. So there is a paradigm shift you are seeing here from the spiritual part of the journey of the industry, where everything is black and white. The good are good, bad are bad, and then towards the point where the line between bad and the good is blurred, and the machine come into the picture. Machine become smarter and smarter. The first era, when the Raja Harishchandra come, then the humans are more dominant. Everything lies in the brain of human, and the human is the decision maker, and they are taking things under control. They are making the firm decision mostly without taking help from the others. But after 100 years of journey, when we see the machine come into the picture, and then the machine started assisting you to take the the decision. And this is what the content of the Robot 2.0. The point which I'm trying to make over here with these two classic picture is that change is inevitable. you have to go with the change, and change are here to stay. The change is the only constant, as we say, is uh, is the fact, right? You have to do the transformation, you have to change with the time. So change is not limited only to the Bollywood, Hollywood, or any other aspect of the life. It happened to the human evolution itself. The human evolved from a unicellular, where we have a one cellular entity like amoeba, and to the multicellular and the complex, the creature like humans. And in between, there are a lot of other creatures as well. So the point is, we progressed, and we processed a long journey from the unicellular to the complex entity to app, and then move forward. Now again, we are at the verge of something which will altogether different from all this. We are transforming ourselves to the form of the digital being. Right, our digital identity is everywhere now. Either it is a Facebook, or the way I am presenting, right, or you go to the Facebook, or you go to the any other social media platform. Uh, the 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 transformation happened, right? Now, from the physical entity, you have a physical entity around 20 years, 30 years back, still you have a physical entity, but the transformation happened in the other dimension of your life as well. Now, as we are seeing that we have our own personality, which is totally digital. However, it is a different thing that your physical personality and your digital personality sometime not in the sync. But in the coming time, your digital personality and your physical personality will merge together. And then whatever you are physically and whatever you are digitally, that line will blur. We will talk about that thing also, if time permits, in last section of this presentation. Then again, the take away from this slide is uh, again to reiterate the point, when the change is showing its way, and how the human evolved from unicellular to the complex being to the digital being. Now the digital is the path of future. Now, when I'm saying that the digital is the path of future, then obviously there are some enablers for that. Now we will start seeing those enablers, because every era is based on some basic characteristic and some basic ingredients. Now, similarly, the digital era is also based on some um, basic fundamental things which we are going to discuss here. Those fundamental things are nothing but data. We will come on to that. As I was mentioning in the previous slide, that every era has their own characteristic. It is not that the characteristic remains same. For example, if we are seeing that the industrial revolution, that are the basic enabler for that is a machine and factories. Similarly, after that, the revolution happened, where we see that how the steam, coal, iron, and railways are changing everything, right? Similarly, the automobile, oil, and pharmaceutical and mass production, all these things are changed, and they become the enabler of a specific era. After the advent of the digital computer, right, or the electronic computer to be precise, which is based on the electronic system, integrated circuit, and so on. So the things are changed. The way we are working are changed. Again, after having a revolution in that field, after 30 years, 40 years, or 50 years of time, again we are on the verge of seeing a tremendous change, and the way of change in the style of working which we are doing now. Now, this change is not like the change of the information technology and the communication change, because those changes are mostly based on data plus the basic electronics, and then after 30 years or 40 years, advanced electronics. But now the era which we are going to visualize is basically a lot of invasive things are coming here to play their role, right? And a lot of smart materials coming to play their role. So we are going to see that how your DNA is going to be modified with the help of the multiple technology available in the biological science. Similarly, we are creating a new material, which material with which material will take its own shape and its own size based on the circumstances around you, right? So there is a new breed of material will come. The what material we are seeing probably it may not be, the 100% will be available at after 30 years or 40 years of time, and then it fuel the something called the quantums that we will see in the coming time in this presentation. Again, the point which I'm trying to make over here is the every era has their own characteristic, and every characteristic is based on some of the enabler. We achieved a lot with the information technology and telecommunication era, which is mostly based on the data, and still we are betting on that, and it is here to stay. Even in the when we talk about the quantum, the data become the crucial part. But there is a dynamic shift which is going to happen now. In between, when from last 10 minutes or 15 minutes when I am talking about few the one thing which is probably repeatedly coming is data change and the revolution. Now all this data change and revolution is here to stay. Now this data is resides and they become a foundation of all the changes which we are going to make. I am using all. Probably this is very optimistic statement or very optimistic verb, but this is the fact. What we are going to do is definitely based on data, and the data is lying as a foundation of this. So again, this may look some familiar to you all, but this is worth spending some time, few minutes over here. That we are generating tremendous amount of data. The latest research came which shows that the humankind is generated data in last 4 to 5 years. The data which they generated in the all of the humanity which generated the data, and those volume of the data is generated in last 4 to 5 years. Those data are of multiple types. Basically, the three types of data: structured data, unstructured data, and the semi-structured data. When we are saying structured data, the structured data is having a structure as name suggests, and it resides in the form of generally in the table and a column format. Unstructured data, which we are generating, is coming from the multiple sources which don't have a structure. When we are saying don't have a structure, uh, it means we can take example of Facebook. That will be easier to explain it. That the Facebook, there are a lot of text written, there are a lot of videos uploaded, right? So those videos and those text which are there is having definitely no structure, right? So those type of data are termed as the unstructured data. And then you have a Excel, and then you have a Word, right? So in Excel and Word there are some sort of a structure is there, some sort of a structure is there. So that's what we are calling them as a semi-structured data. So these data are coming and they gathered together. Why I am talking about the data? Because the previous 3 slides or 4 slides which I was talked about is about change and about revolution. And the next section, what I'm going to talk about is all about how the data is enabling the different technologies. Either it is a machine learning, either it is artificial intelligence, or any other type of the computing paradigm, even the quantum. Right. So all this data become an enabler. So we have to understand data, and that's what this slide is all about. Business. So all this presentation ultimate goal is to give you the insight that the how business is utilizing these data, and what is the direction of the business in now, probably in next 5 years and next 10 years, and then forward through that. So these data when generated, so business are seeing a huge insights over there, but it is very difficult to gather the insight out of the huge data, because as I mentioned that those data are unstructured or semi-structured data. Few of them are obviously the structured. So then there are different technologies exist which will they extract information from there, and then after doing the analysis of this those information, it will give you the insight. It will give the insight to the business. So what technically it means that the you have no structure, you have nothing, you have raw facts. Those facts are massaged together, analyzed, and then giving you some insights. So for example, in the Facebook, you have when you log in, when you take a flight ticket, it will start suggesting you what are the destination where you can go, right? And the location where what are the hotels available which will suits your particular need, right? So this is what you just search a flight ticket, you just put the data, obviously not in the table format, row and column format. You just search for something, it captured that unstructured data, analyze that, and accordingly start suggesting it. So it is a huge benefit for the business to analyze these type of things. So this is what we are terming as a big data. As we are terming as a big data has a some characteristic. We will talk about those characteristic also. But before this, I already talked about that, but just have a look on this. That the challenge is that we are having a tremendous amount of data, and those data needs to be analyzed. Until and unless those data will be not analyzed, those data is useless. Therefore, there is a need of analyzing those data and finding the correlation between them. Let's say that if you analyze the data in the islands, right, you have some information here, some information there, there is no correlation between them, then that data is useless. So you have to find a mechanism which will correlate those two things. So now, from last two slides, what we discussed that there is a data generated, there is a huge amount of data is generated, and those data needs to be analyzed, correlated to each other, and those correlation can be used for the further purposes. Now we need a tool for that. Now, so that tool, it is just I will just mention that it is a machine learning. From basis of that, you can do all those things, but we will discuss that the how part of it in the later slides. So as I was mentioning in the big data slide, that the big data has a characteristic. Not all the data become big data. If you are saying something as a big data, it has some characteristic. The top three, the diversity, volume, and velocity, is the top characteristic of any set of data to qualify as a big data. So first is the diversity. Diversity is obviously the different type of data which we are generating. Data is being generated from the different channels, and it has a different nature, right? So different types of data is generated. So diversity is one of the criteria for term as a data as a big data. And then obviously the volume, right? Because it is not that the diversity we don't have around 20 years or 30 years back. 30 years back also we have a diversity of the data, and data resides in the multiple sections, right? But the volume, as I taken the example of two examples I taken in the previous slide is Facebook, Twitter, and the other social media sites. And even in the organization, right? Now as the organization are looking towards capture the sentiment of the people around them, right? So that they can understand their emotion in a better way, and accordingly reward them or make them more productive for the organization, right? So these type of data, these data obviously have no structure. It is not a DBMS system where you have to put the employee characteristic like employee name, employee phone number, and employee address. These data generally have a no structure, right? So these data is generated in a huge manner, right? So, for example, the black box of a flight, right, or a plane, right, that has a huge data, and that data needs to be analyzed. The ATM videos, when you are going into the ATM, then the camera is installed on the top of that, right? Surveillance camera, right? So these type of data needs to be analyzed, and these are the volumes in a huge site, right? It is not in the MBs, it is in the GBs and petabytes of data, right? So these volumes, so diversity and volume, different type of data, huge volume, and then the velocity. As we will talk in the IoT systems, but when we are moving and when we are on the fly, we are generating a lot of data. Let's say that now we have a sports shoe, right? When you are running in the morning, and then you are putting some bands on your hand, then it is calculating your steps, that how many steps you took, and accordingly you have generating data, and that data is going into the cloud for the further analysis, right? So on the fly, you are generating a lot of data. So diversity, volume, and velocity, these are the main characteristic which qualifies any data as a big data. So if a data set has these three characteristic broadly, apart from that, some is saying three V's, some is saying six, some is saying nine, and some is saying 12, and so on. But generally, these three will qualify a data set as a big data set. Okay, so as I was talking about big data, so one of the main thing which helps to generate these type of data, and which are the enabler of these type of data, is the Internet of Things. Internet of Thing is nothing but your device, the which you are wearing. Let's say that you are wearing a watch, and this watch has the sensor which will capture the health parameters of your body. Or you are running with a Nike shoe, and that Nike shoe has some sensor, and it calculates, or basically it captures the how many steps you took, right? You are going into the car, and then you have a car capturing all the data around you, and then giving you some insight at the, okay, these are the temperature and all those things. The classic example is driverless car of the Google, right? So they are creating a car. Most of you are obviously aware about that. They are creating a car which has no need of driver, because based on the data captured, it will analyze the traffic, it will analyze the road position, and accordingly drive the car with no assistance of driver, right? So again, so first is the device connection. You have a IoT enabled device, and then it has a connectivity generally to a cloud system where it will take the data from you and put it over there, and then capture data through sensor and tags, and then store that data over there, and then data analytics run on that to generate the further insight out of that. And what insight that will be? That insight, when I am saying insight, then what is the meaning of insight? Insight is something which is useful for you. So for example, until and unless you are not seeing dashboard, that the how many steps you worked in, or what is the status of your heart in a graphical format or in a visual format, that is useless information for you, right? So that type of analytics, if come to you, you will come to know instantly, okay, this is the thing which I am looking for, and here I have to do some modification, this I have to improve, this I have to reduce, and all those things. Okay, now I'm talking about a lot of things. As we started our journey from the change, and then we talked about evolution, that how we transform from the unicellular to the multicellular to the digital human being. And then again, we talked about data, where the data becomes the enabler for the modern decision making. In isolation, then you don't have a good analytics, then you don't have a good analysis of that, right? So correlation needs to be established. You have to find the pattern. Okay, these are the data, and these are the general pattern which I am going to get. Out of the pattern, you can see that, hey, this is what I am looking for. So for example, just again taking a Facebook example, if you have a Facebook data, then in that data you have to figure it out that the okay, this data has this set of customer having a bad emotion about this specific product or this specific tweet, for example. This set of customer having the good sentiment about that, right? And this set of the people having the neutral sentiment about that. So how this will be done, how this categorization will be done, how this pattern would be found, right? So this pattern will be found with machine learning technologies. So there are several machine learning tools and technologies that are available, which will enable you to figure it out and find out patterns. And how they do that? Then they are doing that with the help of machine learning algorithms. So then there are huge set of machine learning algorithms. I'm not going into the detail, but broadly, it is a three type of machine learning algorithm: supervised learning, unsupervised learning, and reinforcement learning. Just one liner for each. For supervised learning, you know the input, you know the output, and based on that, you do the comparison. In unsupervised learning, you know the input, but you not know the output, which is level. And in reinforcement learning, it is a reward-based system. If someone is doing good, you are rewarding that. If machine is doing something good, you are rewarding that, right? It is like a dog. If dog obeys your uh, order, then you give a treat to him or her, right? So machine learning actually is all about finding patterns. You will find a lot of fancy and a lot of technical definition of it, but broadly, it is all about finding a patterns out of huge data set, and the machine learning enable them, right? Now, we talked about machine learning, we talked about big data, we talked about a lot of other things. Probably in the next slide, we will talk about artificial intelligence also. But where all this storage and where all this analytics or analysis of the data happen, right? You can do it on premise on your system, but that is something which is out of 100%, only 2 or 3% population is doing at the moment. Probably for the very mission critical applications, like if you have banking, very secure information over there, or you have a government agency where you don't want to they expose your data, then probably you can do that. And that is also on the private cloud, right? But the generally it is done on the the cloud infrastructure. Cloud is what? Cloud is technically, again, there are a lot of definition over there, but technically it is a centralized location where you have a multiple data centers, and on the that data centers you have a memory, you have a compute capacity, and you have a networking capacity, where you are putting in three layers. You are putting the things over there. You are on the first layer, which I am talking about, memory, compute, and networking, which is called as infrastructure as a service. Then you are putting operating system over there, which is you are putting probably the Excel, Power BI, and the Visual Studio. So these type of things which is a software. You need not to purchase all those software. You go there, use it, and pay, right? So all this data which we are talking about, and all those concepts which we are talking about, everything happen on cloud only, at least in the modern time, and most of them, right? So these things are happen over there. The analytics is done over there. The customers or the individuals systems, like it is your mobile or any other machine, are hooked to your cloud system, and from there it is fetching this information and using that information on this. So cloud is sort of enabler for everything, right? We talked about machine learning. So broadly, machine learning is we will see in the next slide, but machine learning is actually one of the subset or the subsystem of AI system, right? And what is AI? Ultimately, the AI is nothing, but it is all about a process of creating a virtual human entity. The ultimate goal of AI is to create a entity which is more like a human and take everything like a human, which is called a general artificial intelligence. However, we are not at general artificial intelligence at the time. We are at something called narrow artificial intelligence, which is very specific work they are doing. For example, chess playing machine. They are very good in playing chess, right? We feed system, feed data over there, and those data are analyzed, and accordingly, based on the opponent's move, the decision are taken. So those type of systems. So that is called narrow artificial intelligence. So again, that is divided into the hard and soft artificial intelligence system. The hard artificial intelligence, which I talked about, is all about human, wherein the other part, broadly or roughly, you can put it into the soft artificial intelligence. So as you see here, in the second part of this figure, artificial intelligence has a multiple subcategory or subsystem. One is machine learning, second one is natural language processing, and then speech, and then understanding a speech. Then you have an expert system, you have robotics, you have a vision. There is another, so robotics, when we talked about, then in the robotics, generally, we have an entity come in our mind like Terminator, like things that the robot come and do everything, but probably it is not. Any small things, vacuum cleaner machine is also a robotics. And then there is another term which is very popular nowadays, is cloud robotics, where everything is on cloud, and it is mostly on the software side. It is a software enabled the robotic system. So this is what I was talking about in the previous slide. AI is a bigger domain, and it has a multiple subsystem, right? But mainly nowadays, which people are talking about, is about vision system. They are talking about different type of problem solving, like decision tree, machine learning, robotics, and the other part of this. So how machine learning work, right? So let's have a very quickly on that, because we are just moving towards time. Time is also one of the constraints here. However, I hate it, but we have to keep track of that. So you have training data, you have a data, you categorize that as training data, and then you have feature. Feature is nothing, but it is an input data, right? So input goes into the algorithm, and then algorithm is run on those input data, and then it gives you model. So model is nothing, but it is an experienced algorithm, right? And then based on the model, you can just make a decision. Whatever the query you have to do, you can do it on model. You will not do in the algorithm or the training data. You only do in the model, right? And based on your query, you can get the predicted output, right? So feature, just mind it, 3-4 things: training data, and then the features. Features is nothing but the input. Generally, it is a very confusing term. Features is an input, label is an output, algorithm, and then the model. Model is nothing but the experienced algorithm, which is trained on the basis of the data which is given to it. And this process is iterative. Every time you learn, you can relate it with the child. Child come into the world after his birth, he has probably no information, and then slowly he visualize his environment and learn from it. Similarly, this algorithm, it's a start from nothing, give it the data, and then it learns from the environment and then mature itself. The one part of it, the machine learning, one of the subcategory of machine learning is the deep learning. Deep learning is a nothing, but it is a layered structure of information which try to simulate human brain. So when I'm saying layered, it means the first set of input goes to layer one, then that is refined, it goes to layer two, then that is refined, it goes to layer three, and then that is again refined, which goes to layer four, until and unless it is not refined, it passes the layer and finally gives you output. So this broadly we talked about. I will skip it. Okay, just quickly have a look on this, that how the machine learning generally work. First, anything which starts from the business objective and hypothesis. It is nothing but a business statement which says that this is what we are trying to achieve, one-liner statement, and then from that we have a multiple source of information and we have a lot of data. So we have to prepare the data. Not all the data is useful, right? So we have to refine data, right? So data preparation is a very important step where you can remove noise. Noise is nothing but the impure information, right? You have to remove impure information, and then you prepare a data. Then you come to the model planning. Based on the data which you have, you create a model, right? Model, remember, model is nothing but a experience algorithm. Then the model is developed, and after the model is developed, as I mentioned, that the whatever you have to do query in the production environment, you will do the query in the model only, right? So you can do the query over there, and out of that query you fetch insight, right? So that is what the drive insight. And then again, this is, as I mentioned in the previous slide, it is an iterative process based on the data, based on training and retraining. This process goes on, and then the model is further optimized. Once it is optimized, you can start using that. Then again, you have a new set of data come, you will again put, and then again you have to follow the same cycle. These are the few area of applications where the machine learning can be applicable. Probably I'm not giving a lot of emphasizes on all this because generally these information I assume that you have, but for the completeness, just have a look on that. This is speech, handwriting, and face recognition. These are the areas where the machine learning are used. So self-driving car, and then again the pattern recognition task which we talked about, identifying fraudulent activities proactively. So how to identify fraudulent activity? Let's say you are working in a bank, right? And then as I mentioned that the patterns are there, right? So you have a user patterns captured over there. Now one day you are seeing Skype in one of the activity. Then you can just figure it out. Why this happened, and then again you try to investigate, and probably that may be one of the source for fraud related activity. So any unusual patterns, it will able to figure it out, right? Similarly, the medical research diagnosis, again a very dearest topic for most of the researcher here. One of the use cases which is very much in demand is IBM's Watson system. So what it does that it will take all the scan report of a patient, and then at the same time it will search all the knowledge based medical research journals across the globe on all the digital libraries which are available, analyze that, and based on all this analysis, based on based on the all the scans which it has, and then the previous existing scans also, it can throw the result that the okay, this may be the cause of this disease. So for a classical example is cancer. So let's say that the patient is suffering from cancer, then a tissue, all the result of a tissue is go into that. It will analyze that, and based on the behavior of the tissue and the characteristic of the tissue, it will say that this patient has a cancer or not cancer. So just have a look on that. Okay, so this is what we are talking about, and then there is a term called Industry 4.0. Industry 4.0 is again nothing but it is just that the how we are using these innovative technologies or the digital technologies which we are talking about. Either we are using big data technologies, we are using cloud technologies, we are using blockchain, we are using the other thing, and applying that to the industry, right? So that is what the Industry 4.0, right? In Industry 4.0, instead of traditional industry, which is a land, labor, and machine based, this industry is broadly based on the digital infrastructure, right? Wherein you have the digitally you can do most of your time, most of your task, and less dependent on the physical infrastructure, right? Even you have a physical infrastructure also, then the processes there in the physical infrastructure, let's say that you have a car making industry, right? In the car making industry also, you installed a lot of sensors there which can analyze the happenings in the real time, which will say that the in which particular equipment the fault is expected before the fault is going to occur, right? So these type of things will be helpful for the industry, right? And that's what there is a term coined for that, that is Industry 4.0. So technically I covered all the things, and then the at this point typically the presentation over, but this presentation is not going to end over here because the final slicing is still need to be discussed. I know that I have 3-4 minutes to cover that, but I will try to to cover that. So these things which we are talking about is whatever we are exposed to the current systems, whatever the systems which we have, whatever the technology which have, there is something which is already going, and then there are a lot of things are happening over there. Until those things will not come into those things not come into the picture, the discussion which we are having is not going to be completed. So anything, according to me, which stops here is probably not having any worth, because until and unless we will not talk about the future, that the what going to happen in the coming time, then the picture is not complete. So here the quantum computer pitch in. So what quantum computer is, if we remember the first slide, second slide which we are talking, third slide, sorry. If we are the third slide which we are talking about the different type of technological revolution, right? So the fourth industrial revolution is all about using those digital technology, but the fifth industrial revolution is circled around the quantum computer, because this type of system is going to change the system for forever, right? It will change the way we live, it will change the way the technology works. So what is quantum computer then, right? So it is not based on the traditional. So just for the audience, the traditional computer is based on 0 and 1, right? So either one of the state is true, either it is 0 or 1, and based on that, the register circuits are created. The information is passed in the register and circuit, and accordingly the processing will happen. But in the quantum computer, it is based on the principles of physics, and to be precise, it is based on the principle of quantum physics. So in quantum physics, everything is fuzzy, right? There is no Boolean here. There is no clean segregation. There is no black and white. Everything is fuzzy, right? You have to see that something is wrong at the same time that is good also, right? Seems crazy, but that is a fact. And this is what, the lot of scientists, given there a lot of heads over there, but ultimately not able to figure it out the solution, right? So in quantum physics, what we are saying, 0 and 1 is called bits. In quantum physics, it is saying qubits. So qubits is uh, it is a analogous to 0 and 1 in the classical term, right? So it will stay in the two states at the same time. How? Then there is a phenomena in quantum physics called superposition. Superposition allows superposition allows to stay in the two state at the same time, right? So that is one. And then this enable you to be in the two state at once. And then let's say that you are passing some information over there, and then that information will be analyzed simultaneously, because in the world of traditional computer you are doing one by one, but here you are doing all the processing at the same time. Best example is take that you have a 50 shirts. Now in the world of traditional computing, what you will do, you will just feed the system that I want out of this 50 shirt, one shirt is clean, and then give me that shirt. The system will do that it will take first shirt and check that it is clean or not. Then it will go for the second, and then this worst case scenario, it will go for the 50 shirts, and finally it will find the 50th shirt is the clean shirt. But in the quantum computing world, what it does, that the 50 shot is in line, it will one shot, it will go there and figure it out that the which shirt is clean and which shirt is not clean, right? Obviously, the result will come as a no, 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 yes, no, 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 something like that 50 times, right? But in one shot, it will do the computation. How this will happen? This will happen with the superposition, and then there is something called entanglement. With the help of superposition and entanglement, it will happen. What is entanglement? Entanglement is two qubits relating two qubits to each other, right? And how it will be done? It will be done through the something called laser technologies. With the laser technology, you can entangle two qubits together, right? So two concepts here. First is superposition. Superposition allows you to uh, to mix the state, right? And entanglement allows you to entangle two qubits. So in the classic example of the shirt, here you have first you apply superposition, which 50 qubits come together, and then to make decision, those qubits needs to work together. How they will work together? With the help of entanglement, because they are entangled, right? So this is the beauty of the quantum computer. Now just see, just visualize that how fast your calculation is. In that scenario, you will go sequentially. Here you can go 2 to the power n, right? You can just go, if you have a 2 qubits, 2 to the power 2. If you have a 3 qubits, then 3, then 4, then 6, and then just after 50, you just imagine that how long you reach or how far you reach. So this is what the quantum computer is all about, and that's what there are a lot of traction over there. Now, why it is not in the market? Due to some obvious reason. Because the quantum computer is not like the traditional system. It need a super cooling environment, at least as of now. There are a lot of research going on, and probably in future we need not. It needs super cooling environment where, because the quantum states are fragile, it is very much fragile. So you need a stable quantum state. So for a stable quantum state, what you need to stable it. And for that, you have to go for Kelvin zero, right? And then you have to, the make that state as a stable state, right? So that's what it is so difficult, right? Error correction. If there is an error, 0.5% error is acceptable. If you have a 1% error, then whatever the qubit you add to each other, there is no processing at all. But if you have a below 0.5% of error, then you can do miracles. I will quickly navigate. So that's what I was talking about. In the coming time, EC Industry 4.0, quantum technologies, AI and IIoT, which is industrial Internet of Things, will be the future. These are the few specific area of application of quantum computers. Now, one thing which I want to mention over here, that quantum computer is not like a computer which we have today, right? The quantum computer is a very specific cases. So for example, if you do have to computational chemistry, you have a separate quantum computer for that. You have to do machine learning, you have to do separate quantum computing of that. And quantum machine learning is nothing but same thing. You use quantum technologies. Now just see that how the power of machine learning in the quantum world will increase. You have to analyze the data. You have the qubits, and the qubits are entangled to each other. Qubits are superpositioned with each other, and whatever the huge data comes to you, you can just analyze in a very quick manner. So you can make decision in a super fast way. Even a saying is that the quantum computer enabled with the machine learning will break the hardest problem of the world, which will take a traditional computer to take thousands of years. Quantum computer will do in 1 hour, right? So these are the use cases of quantum computer. Uh, yeah. Okay, to concluding remarks. So, what I'm trying to visualize in this picture, if you visualize, so at the moment, what we are seeing that all this big data, cloud infrastructure, and we are talking about the IoT and all those things. It has a huge impact on what our day-to-day life. But in the coming time, this is going to be blurred. As at least in next 30 years, it is going to be a blur. And in next 10 years onwards, you will start seeing that. And then more human-like computer will be created. The computer which have a more human orientation. It is not just a mere decision-making machine where you just input data and do the things. It will be the system which will analyze, which may think also, and then accordingly take a firm decision. So the field of psychology, field of sociology, field of philosophy become dominant instead of field of the technology like Internet of Things and big data and the other aspects of it. Finally, before we close for today, this is what the future which I am visualizing, and this is not me. There are a lot of research across the world is seeing that ultimately the humans and machine will merge together at some point, where it is very difficult for you to identify that who is human, who is machine. Now, seems like a science fiction, but this is something which is started. Even the Elon Musk Neuralink is already implanted the chips in the human brain to analyze the human thought process, right? So this is what the future is all about. With this optimistic note, I'm thanking you and take a pause and open for questions.